Good morning, students. In today's class, we'll be doing the topic molarity. It is a commonly used concentration term to prepare solutions in the chemistry lab. Your titrations also have solutions in which their molarity is provided to you. Molarity is always represented by the alphabet capital M. Since we are talking about a solution, any solution has two parts. One, the solute, and the other is the solvent. As a rule, I would be referring to the solute as B and solvent as A. There are books which refer to solute as 2 numeral and solvent as 1 numeral. We move on to the definition first. Molarity is defined as the moles of solute dissolved per liter of solution. The units are therefore, since it's moles of solute, moles upon liter is your unit. The formula for the same, molarity, is given by your moles of solute divided by volume of solution in liters. Representing it, small n always is given for moles. Moles of the solute, I'm using the alphabet B for solute, divided by volume of the solution. So no A and B because it's the solution. You are talking about the volume of the solution in liters. Moles are always calculated by the formula your weight by molar mass. Therefore, elaborating it up, the given mass of the solute is W upon molecular mass of the solute, which you will be given because your atomic masses would be provided to you, into volume of the solution in liters in the denominator. That becomes your formula to calculate molarity. I'll rewrite it up for you. WB is the weight of the solute. MB is the molar mass of the solute. Volume is for the solution, and you remember it, it is to be taken in liters. Moving on to the first numerical to drill the concept a little better. The first numerical says you have to calculate the molarity for a solution which is prepared by dissolving 4 grams of NaOH in 200 ml of solution. For this question, you would be given the atomic masses of sodium, hydrogen and oxygen. For oxygen it is 16U, hydrogen it is 1U and sodium is 23U. For some of them I would always advise that some of the atomic masses you should know. The common ones like carbon, hydrogen, oxygen, etc. But the rest are generally provided. They are to be provided because you're not expected to learn the atomic masses for all the elements. Now, first of all, the first step would always be you write the correct formula and fetch your marks for the formula part. That is your formula. What is WB? Weight of the solute. In this question of the solution, what is the solute? NaOH. When there is no solvent given, it's understood it's water. Weight of solute becomes 4 grams. What is the molar mass of the solute? You need to calculate what is the solute? NaOH. How much? 4 grams. You've mentioned it in the numerator. The molar mass is to be calculated. Sodium is 23. Oxygen is 16. Hydrogen is 1, which makes it 40U. So you have the 40U is your molecular mass. If you represent this in grams, it becomes your molar mass. So this value is your 40 grams. The volume of solution in liters. How much was the solution? 200 ml. Those of you who are good in maths can easily report it as 200 ml, that is 0.2 liters. But those of you who are not, I would advise you divide it by 1000. So the values that you get now are 4 divided by 40 multiplied by 200 and you had 1000 in the denominator, which goes into the numerator. Calculating it. 1, 2, 3. 1, 2, 3. 4 goes with 4. You're left with 1 by 2, which is equal to 0.5 m is your answer for the question. I'll be doing one more question for the same topic. You have to calculate the amount of KOH and you're given half a liter of the solution. You're given 0.2 molar, which means your molarity values are given. Whatever said and done, you first need to write the chemical formula for it. Molarity is weight of the solute upon molar mass of the solute multiplied by volume of the solution to be taken in liters. Let us put the values as per the question. What is the weight of the solute? You need to calculate that. So this becomes your question. How much is the molar mass? For this, KOH, potassium given is 39. Should be given in the question. Oxygen 16, I prefer that you should know it. Hydrogen is 1. This value comes out to be 56. Volume of the solution in liter. Half a liter is 500 ml. So 500 ml, or else you put it as 0.5. That's up to you how good you are in maths. Substituting the values, you're still left with capital M. Molarity was provided to you, hence it is 0.2. So your workup becomes 0.2 is equal to WB you need to calculate upon 56 into 500 and you have 1000 in the numerator. Calculating the value of WB from the above. Let me remove the zeros and the 5 and the 10. You have your WB is left over. Your WB becomes 0.2 into 56 divided by 2. The value comes out to be. Here you have a cancellation here. This ends up in 5.6 grams of KOH is required in the answer for the question. With this, I end my class on molarity. Thank you.